All right, starting lesson 2.2, prove statements about segments and angles. Now, here we have some very helpful tips for completing a proof. All right, so if possible, always label the diagram with the given information or newly acquired information. All right, labeling a diagram can make useful information stand out, which may have not otherwise. So use tick marks for congruent segments, arcs for congruent angles, numbers for side lengths. All right, so for example, 1 says given BD bisects angle ABC. So that means we know it cuts the angle in half, and these two angles are congruent. All right, or they have the same measurement. All right, for part 2 here, analyze all the previous statements when trying to determine how to get the next statement in the proof. For example, sometimes the fifth statement can be constructed using information from the first and fourth. All right, be aware of that. All right, so we start with this information. There's some information in the diagram. This is what we want to get to at the very end. That's what we have at the bottom. All right, so starting off with statement 1, BD bisects angle ABC. That's given. All right, for 2, angle ABD is congruent to angle DBC. All right. And how do we know that? Well, just look over at your yellow sheet. That's the definition of an angle bisector. All right, going on to statement 3. All right, measurement of angle ABD is equal to DBC. So we went from congruence to equality. Whenever you do that, that's just definition of congruence. All right. For part 4, ABD plus DBC is equal to ABC, the whole thing. All right. Well, how do we know that? That's just the definition of, or I shouldn't say definition of, that's just the angle addition postulate. All right, it just means the sum of the two smaller angles gives you the larger one. All right, for part 5, measurement of angle ABD plus measurement of angle ABD equals the measurement of angle ABC. All right, where did that come from? Well, notice that these are the same, but going from here to here, there was a change. All right, DBC turned into ABD. Now, how did that happen? Because these are the same here. All right, we'll go back to this piece of information. I know DBC is equal to ABD. So that's why it changed. All right, essentially, what did I do? I just used substitution. Okay, and going on to part 6, I have 2 times the measurement of angle ABD is equal to ABC. Well, what's x plus x? 2x, right? So ABD plus ABD is 2ABD. That's just simplification. All right, now why is it not addition? Because you're not adding something to both sides of the equation. You're just adding up like terms on one side of the equation. That's simplification. Okay, and then now we have measurement of ABD is equal to half of ABC. So what happened to the 2 here? Well, they divided by 2 on both sides. So they used the division property. And then we end up with what we're trying to prove. Okay? Let's do some more examples. All right, given AC is equal to BD. All right, AC is equal to BD. All right, they're the same length. All right, so the reason the beginning is given. All right, then it says AC is equal to AB plus BC. Well, yeah, the 2 parts of it make the whole thing. So that's just the segment addition postulate. All right, get really familiar with the yellow sheet. I'm going to be using it very often. Then we have BD is equal to BC plus CD. BC plus CD. All right, so that's the same thing as before. The two smaller pieces add up to a larger piece. Alrighty. And now we have AB plus BC equals BD. Where did that come from? All right, and here's where you have to analyze the previous statements. Okay, so I have AB and BC. Where else do I see that in my previous statements? Right here. All right, well, it's currently, or before, it was equal to AC. Then it changed to BD. Right, how did that happen? All right, well, look at what we have here. AC is equal to BD. So you could just substitute it in, and that's how you end up with BD. So that's substitution. Okay, now I did this intentionally because every year students do the same thing. Now this is a form of substitution that we just used, but it's a specific type of substitution. All right? Because here we have these two links, right? They're both equal to the same thing, so we set them equal to each other. When you're doing that, setting them equal to each other, that's a more specific form of substitution. That's the transitive property. Okay? So whenever you have two expressions equal to the same expression, and then you set them equal to each other, that's a transitive property. All right, and then going on to 5, we have AB plus BC is equal to BC plus CD. Where did that come from? All right, well, BD is equal to BC plus CD. So same thing's happening again. This is the transitive property. All right, watch out for that. It's a specific type of substitution. All right, and for part 6, what happened? Well, the BC's gone. Subtract BC from both sides, it disappears. So they just use the subtraction property. All right. It just takes practice to get used to doing these types of problems. The more you practice it, it just becomes second nature and it'll be really easy to do. But you don't learn this overnight. You got to practice it day by day. All right, and the last example. B is the midpoint of AC. So if it's the midpoint, what does it do to the segment? Cuts it in half. These pieces are the same. All right, so statement 1, B is the midpoint of AC. That's given. All right, and then it says AB is congruent to BC. How do we know that? That's just definition of midpoint. All right, then it goes from congruence to equality. So that's definition of congruence. Then it says AB plus BC equals AC. So AB plus BC equals AC. That's just the segment addition postulate. All right, and then it says AB plus AB equals AC. How did that happen? Now that stayed the same. That stays the same. This changes. How did it change? Well, they just substituted, right? AB became, or sorry, BC became AB. So here we have BC. So now we have AB. That's just substitution. All right, then we have AB plus AB is 2AB. All right, we're not adding something to both sides of the equation. We're just adding two like terms, so that's simplification. And then how did we end up with AB equals half of AC? Well, they divided by 2. That's the reason for this statement. All right, in the beginning, proofs can seem very tedious and challenging, but once you get used to doing them, they'll actually become very easy to do. All right, if you have any questions, please make sure to ask. Begin the assignment.